Welcome everyone. In this video we're going to be taking a look at FutureProviders and AsyncValue, and we will continue making this to-do app, and the actual code for this is entirely not important. The concepts are important, and that is what we will focus on in this video. The logic about how we can use FutureProviders and AsyncValue that will provide some fantastic benefits when using Riverpod. And if you stick until the end, I think you will learn a lot, especially with regards to how you can use AsyncValue to really clean up your code. And as always, the code for this will be on GitHub, so you can check it out there. Before going into the more advanced topics of this video, let's quickly do an overview of FutureProvider and AsyncValue in general. And for this, I've made a little bit of an example. So this example that we have here is just an example FutureProvider. So I'm just gonna save this and just do a hot restart. And now you can see that we have a HTTP response on the screen. And if we take a look at the code, you can see that we have a provider that's called TestFutureProvider, which is a future provider. And a future provider allows you to also make your functions asynchronous. So in this asynchronous function, you can see that I'm doing a GET request to google.com and I'm awaiting for the response. And the response, I'm returning the string value of that. And you can see that this future provider is marked to be a string. So essentially we will be returning a string. But actually we won't be returning a string. We will be returning a async value that is a string. And what is an async value? Well, that is something that Riverpod provides that allows you to quickly map over the different states of the response. Let me explain that by actually showing you the example. So in our widget over here, we have a consumer, and then we're using the watch method to watch the TestFutureProvider. And now the thing to take note of is that this response, if we take a look at the value of this response, you can see that this is a async value of string. And an asynchronous value is basically a union. And if you're not familiar with what a union gives you access to different classes or different class hierarchies. So on this response object, we have different methods that we can call. We have whenData, map, maybe when, and when. So let's quickly take a look at map. And if we autocomplete this, you can see that map gives us access to three different functions: data, loading, and error. And the data function will give us access to the async data class with the value of string, and loading will give async loading, and error will give an async error. All of these of type string, because that's what we marked the future provider to be. So map will give us access to the class, and when, on the other hand, will give us access to the variables. So basically the fields that are defined in the class. So in the data now, you can see that it's returning a string, and loading is returning nothing, and error, if it will load, will give us an object. So this is the error message and the stack trace of that error. And if we quickly just explore async value, so I'm just going to type this out, and let's jump to that. You can see that in the async value, we have these factories: async value data, loading, error, and you can see that these different methods return the different classes. And I do believe that the package actually uses freeze to generate these classes, but it also provides some additional methods or additional icing on top of what freeze does. And if you're not familiar with what freeze is, I highly recommend that you go check that out. And as I'm saying this, I'm actually seeing that, yeah, the package freezed, which have generated this async value class and explains how map when works. So yeah, if all of this is a bit confusing, I definitely suggest checking out the package called freezed. It is made by the same person that made Provider and Riverpod. So shout out to Remy. Thanks for all of these fantastic packages. In an upcoming video, I will go into more detail on using freezed and how you can use it with Riverpod. Because when you're using these two together, you can really make stuff that would normally be hard to do easy and trivial. But that said, you will see the benefits of using freezed just by taking a look at what AsyncValue does. So if we go back to our explanation, Just going to remove that. You can see that we are calling the when method, and this gives us these three functions, okay? So I've already typed this out at the bottom. So you can see that in the data, we get the response. So the response is basically what gets returned by the future provider once it actually completes. And then we have the loading state, so we'll show a circular progress indicator, and we also have an error state. So if this future provider were to throw an error, then we can actually gracefully handle that in our UI. So let's save this, and I'm going to do a hot restart, and you'll see that we get loading. So that initial loading is this, and then when the actual feature completes, we get the response from google.com. If we were to just put in random stuff here and do a refresh, then, and let's just go through these exceptions, then you can see we get the error message. So now we are printing this error over here, and it's just telling us what went wrong. And you can see that we failed to look up the host, this whatever this.com is. In addition to when and map, you can see that we have when data, maybe map, and maybe when. You can use when data when you only care about receiving the actual response, and we will be using this throughout this video. So I'm not going to go into more detail now. We will not actually be covering maybe map and maybe when, but both of these are also very nice. Maybe map basically gives you an additional or else. So the or else needs to be there, and the or else is if you do not cover one of the conditions. So one of the conditions for this map that we have in the async value is that we either have a data, a loading, or an error. So when we use maybe map, we're essentially saying that we only want to use some of them. So if I want to use the data one as an example, we can still get value to the response, and then we can do whatever we want with that response. And we do not need to handle the loading and error condition. We just need to handle this or else condition. I never actually use maybe map for async value because you normally want the data loading and error states to be handled. But when using freezed, maybe map is fantastic. And in a future video, we will go into more detail. The same is true for maybe when, but that time you get access to the actual fields instead of getting access to the entire object. Okay, so with the primer out of the way, we are just going to remove this example code, and let's get back to our to-do application. And you will see that we actually are getting an error with this to-do application, and that is because I've built in like a random chance that there could be an error state in the to-do app. And I think that's a good lead in to jump into the repositories folder. So again, the code is not important. The concepts are important. So you can call this services, you can do what you want. You do not need to structure your code in a certain way. This is just for demonstration purposes. So I have an abstract class called to-do repository, and then we're defining a couple of these methods. And you can see that I am implementing that to-do repository and calling this fake to-do repository. And all of this just simulates basically what you would do if you were actually making HTTP requests. But all we're doing here is just manipulating some mock to-do storage. So if you want to take a look at this code, you can do that on your own. Each of these methods do the exact same thing basically. For example, in the add to do, the first thing that we do is we wait a random amount of time. So this is just a method that I defined. So we're waiting anywhere between 0 and 3 seconds. And then we are doing a check to see if we should throw an error or not. So I'm using a random that's created over here in the constructor, and then saying next double, and if the double is smaller than the error likelihood, which is a constant set to 0.4, then we will throw an exception. Otherwise, we will just update the state on our mock server and continue. But if we do throw an exception, that is something that we will handle in a different part in our code. And you can see that this to-do exception implements exception, and we can pass in an error message, and then we just override the toString method. And that is basically that, or what you need to know. You can explore these individual methods on your own if you want to. They just do different things to manipulate the mock state. One thing to take note of is the fact that I'm calling this a fake to-do repository, because this is clearly not a real repository, or it's not doing real server requests. And you will note that in our to-do state, so this is where I'm actually defining all of the different providers, you can see that here we have this to-do repository provider. And by default, I'm actually saying that we should throw unimplemented error. And that is because I haven't implemented the real to-do repository. We only have the fake to-do repository. However, in main.dart, when we initialize Riverpod, you can see that I'm using the overrides within the provider scope, and then I'm overriding the to-do repository with the fake to-do repository. So just to be more clear, I'm just going to mark this as overriding for testing and just spell overriding correct. I didn't need to do that for this demo, but I thought I would just show you how I normally do my own fake little repositories. So going back to our to-do state, as I said, this is where we basically initialize all of our providers, and this is also where we have our to-do notifier, which is a state notifier, and this is where the actual magic will happen, or the truly wonderful thing that I want to show you in this video. But before we delve into that, I realized I didn't go into the models. So we have this models file that just exports these two different models, and this is just so that we can import one file instead of importing both. And then the settings, this is this menu bar over here, not important at all. And then we have our to-do model as well. If you want more information on this, then do check out the previous video that I made. Anyway, going back to to-do.state, you will note that our StateNotifier looks a little bit complicated. And that is because instead of returning a state of list to do, as we did in the previous video, this time I'm returning an async value with the state set to list to do. And the reason I'm doing that is because for this StateNotifier, I basically want to have the benefits of a future provider without using a future provider. So what do I mean by that? As you can see in this constructor, I'm basically setting the value of the initial to-dos equal to AsyncValue.loading. So unless when this is constructed, unless something is passed in, we're doing a null check. If this is null, then I'm setting the initial state to be AsyncValue.loading. So this means that when we do a refresh, for example, you will see that we get this loading state. And if we go to main.dart, that is exactly what happens. So let's just scroll down to where we actually have our to-do list. And you can see that here we are listening for the to-do state, which is the to-dos notifier provider, which returns the to-dos notifier. And then we are checking the state. So on this to-do state, we are calling when, and then we are handling the data situation when we get data, when we have loading, and when we have an error. And if we refresh this enough, then we might trigger the error condition. So now you can see we have this error condition, and that is because of the to-do repository where sometimes it would throw an error. So let's do a refresh again. We get our loading state, and this time we didn't actually see the loading state just because it happened so fast. So let's try again. We get loading, and then after that we get the data. So in our constructor, the thing that we do after setting the state to loading is we call the private method retrieve to-dos. And in retrieve to-dos, we are calling our to-do repository, and we're calling the retrieve to-dos method on that. So if we jump to this, you can see that this is something that's defined on our repository. So let's go back, and you will see that we get access to this to-dos repository using this read method. And this read is something that we pass in, and this is a reader. And you will see that when we create this to-dos notifier, we pass in the ref.read. So this is the ref that we get here. I provide a reference. If you need more information on this, I suggest you watch the previous video where we cover reading providers in detail. But yeah, after calling retrieve to-dos, we get the value by awaiting it. And then what we're doing is we are updating the state using AsyncValue.data. We could also technically say that this is async data and give the data like this. This way is just a convenience method, so you don't have to remember the different class names. As you can see on this, we can set this to be data, error, or loading, and all of those are valid. And we do exactly that because we are doing this in a try catch block. So we are trying this and we are listening, or we are catching a to do exception. And if there is a to do exception, we basically set the state to now be an AsyncValue.error. And if we do that, that will trigger our UI. So when we do the when on the to do state, that will trigger this error method or this error function, which will then return the error message that we define. And that's the main thing. This ensures that we always handle the case where we have data, where we're loading, and when we have an error. And it really cleans up our UI. In this instance, it might look a little bit messy, but we can always just extract this to be a separate widget, and we can extract this to be a separate widget, and the same for the data states. And then the code would be a lot cleaner. It's also safe because we are ensuring that we are handling all of these situations. One thing to note though is that using async value can become a little bit complicated, and you will see what I mean by that when we take a look at these other methods. Because for the retrieve to-dos example, it's fairly straightforward. We're just setting the initial value. But if we're updating values that are already existing, then it becomes a little bit harder. And this is where I'm also doing something a little bit unique, and maybe there are better ways to do it. But if we take a look at the code over here, let's add a to-do. You can see that it gets added successfully. However, I've made it in such a way that if the to-do fails to add, then we will get a message that says it didn't add successfully, and the state will be reset. So let's refresh this, and you can see that now the error likelihood is 0.9. So it means that it most likely will throw an error. So I'm just going to say test, and you will see we get to-do could not be added, and the to-do was removed again. Same for deleting it. It deletes it locally, but then the server says, sorry, we couldn't delete the to-do, and then it resets the state. So let's see how I did that. We'll go to the to-do state, and we will maybe take a look at the add. So in the add, we pass in the description, and the first thing that I do is I call this method called cache state. So this is something that I defined, and I'm just setting this local field called previous state to be equal to the current state. And as I'm saying this, I just realized that I'm saying state.whenData value returns value. This I just did for testing purposes. Technically, I can just set this to be equal to these states. So yeah, I'm setting the previous state field, which is defined up top here, to just be equal to the current state. And then what we're doing is we are setting the state to the new value. So what we're doing here is we are unpacking the current state, and I'm doing this based on the value because we need access to the list of to-dos. So remember, our state is an async value. So this is where that when data comes into play. So we're saying state.whenData, and this will give us access to the list of to-dos. So let's be a bit clearer here and call this to-dos. So I'm unpacking all of the current to-dos that we have, and then I'm adding another to-do with the description set to what we pass in here. And the fact that we are doing this within whenData, that means this will actually return an async value of whatever type it is. So that's an example of how we can update our async value. So after updating it locally, what we're doing then is we're doing the actual server request or our repository request. So I'm doing a try, and we're trying to add the to-do to the repository, and then if there's an exception, we handle the exception. So again, in this instance, if we add something, it's very likely to throw an exception, as you can see at the bottom there. And if we wait a second, okay, so this one actually was successful. So this was in that 10th percentile, it actually worked, but this one couldn't be added. So in the handle exception, what we're doing is we are resetting the states. So reset state, we're just checking to see if this previous state field is null or not null. If it's not null, then we reset the state to the old value, and then we just set previous state to null. And then after that, we actually use the to-do exception provider, and we are setting the states on that to be equal to the exception. And what is this to-do exception provider? This is just another provider that I made that is a state provider with state to-do exception that's initially set to null. And then if there is an exception that occurs, we just set the states to that to-do exception. And then in our main dot, I have a provider listener. So I'm just going to search for that. You can see here we have this provider listener. And a provider listener is like a consumer, but it only listens for changes on a provider. So it won't cause a rebuild in your widgets. All that will happen is the onChange method will be called. So provider listener is fantastic to doing exactly that, just listening to changes in a provider. So you can see that here I give the provider to be the to-do exception provider, and then we have this onChange that will be called every time the to-do exception provider changes, which gives us access to the context and the states of the provider, which in this instance is a to-do exception, but wrapped in a state controller. So all this means is it's just the value returned by this state provider over here. And then in this function, I'm just creating a snack bar, and I'm setting the snack bar's text to be equal to the error message that we get in the to-do exception. And you will note that the to-do exception gets a different error message depending on the exception that occurred. So fantastic. That is basically all of it. All of these other methods are basically doing the exact same thing. They're just doing it in a different way, or in a slightly different way. So if you want a complete example, then you can take a look at this code. In future videos, we might build more on this to demonstrate other features of Riverpod. And as I said, I definitely want to do a video on using freezed and to go into more detail on using unions. And with that said, I think we are done with this video. It was a lot of information, so please feel free to ask for additional info down in the comments, or if anything was unclear, I can make follow-up videos that discuss this in better detail. Also, please let me know what other Riverpod content you'd like to see, and if this video helped you, then share it around, or leave a like, or tell your friends. And yeah, until the next video, cheers.